Yeah, hello. In this video, we are going to see how to create, that means how to use Excel for digital signal processing. Here, generally, we find what we do is whenever we are implementing we have to plot a wave or a signal. We need to create digital values of that particular signal. Okay, and to do that, that means we implement that means if we are creating, let us say if I want to create a sine wave using some microcontroller on a FPGA, then I need to have a lookup table having the values of the required sine wave. Then the question is, how will I get the sine wave value? One way is you can use a MATLAB and do it, and the other way is you can use an Excel. Excel will be a bit what you call easier to use. Let me show you how. Okay, so let us say if I want to generate a sine wave, what I will be doing is I will be simply writing the formula, required formula is equal to sine two into pi. Pi is not a constant in Excel, it is a function, so therefore you have to use the braces, divided by n. N is here represents how many samples you want from a particular in a particular sine wave. Okay, so generally you can have that means 8 samples or 16 samples, 32 samples, 64 samples. That depends on what is the that means precision, how fine you want to make the wave. Let me make it for 16 samples, so 2 pi divided by n, capital N, and here you have instances. So what is this instances? That means if you want to know what is the value at t n is equal to 0, 1, 2, 3, so that n is going to be variable, that n is going to produce different values of sine. So that n, what you can do is you can select a different cell with other cell for giving a variable value. Okay, just click on it. Okay, so now I will plot the n values. Okay, so let me show you what is this n I am trying to plot here. Okay, so if I have this equation sine 2 pi by n into n, so this is my f of n I am trying to plot. Okay, so here this 2 pi by n represents 2 pi is the time period, that means it is the duration, that means 2 pi phase change. So for a 2-point phase change, within this 2-point phase change, 360-degree phase change, how many samples I want? So if I say 8, then it means I am going for 8 samples. 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 samples. So like this, if you want a higher precision, you can go for a what you call higher samples, 16 samples you can go within this. So I have chosen n to be 8, this n I have chosen to be 8. So therefore my equation is sine 2 pi by 8 into n, where n is your variable. So this is your f of n. So n is equal to 0, you will get up one value, 1, 2. So for different instances you will be getting different values from this equation. So this cell, whatever is present here, is going to represent the n values. So let me start with 0, 1, 2. Okay, so what you need to do is simply drag it to get the remaining values. So 16, right, actually 16 is not needed, you know, as we are starting with 0, so the 16 value will be the is represented by the number 15. Okay, that is going to be your 16th sample. Now this equation, whatever we have here, that needs to be copied into the remaining cells, these cells. So in order to do that, the simple shortcut in Excel is just click on this point, drag it until where you want. So this will give you all sine wave. So if you don't believe me that this is sine wave, I will just show you. You can click on this insert and then this dots. Okay, this will give you a assignment. Now you can see these are sine wave whatever I produced with 16 samples. 1, 2, 3. If you can count the samples, there will be 16. Okay, right. So here the thing is, this sine wave whatever is produced has an amplitude of 1. Okay, if you don't want an amplitude of 1, let us say if I want an amplitude of 2 volts, then you can have 2 here. Okay, and 2 into, I'm sorry, sine wave, this enter. Okay, the same formula needs to be copied in the below cells. So when you copy it, it will be changing for 2 volts. So here it gives a sine wave which is both positive as well as negative, and generally we know, see this DAC, where this wave whatever you produce through a microcontroller, ultimately you will be using a DAC. Okay, that DAC will work on integer values, and these are decimal values, and they are negative values. So how to convert this negative to positive is you simply add a DC. Okay, a DC voltage you can add to plus. So when you add a DC voltage of equal amplitude, you will get all the positive values. Okay, so this is the equation. In order to just extend that, just drag it. Now you get the values. Now you see that these equations have there are a few decimal values, there are a few integers and all those things. But whatever DAC we use, it doesn't the input to the DAC will be a digital value. Okay, if this is my DAC, this DAC will be having all digital values. Okay, and it will be giving an analog voltage. So I have to create this digital values. So digital values, in order to create the digital values, and most of the DACs require the digital value in what you call integer form, and they will not suppose this decimal format. So what you got here are voltages. You have to convert these voltages into the appropriate hexadecimal value. So how do you convert this into a hexadecimal value? Is simply you divide this voltage by the step size, and the step size with the DAC which I have used is 0.02. So therefore the voltage what you are going to get here is equal to that means the hexadecimal value for getting 2 volts is 2 divided by your step size, which is 0.02. Okay, so that means when you give input as 100, decimal 100 to the DAC, it is going to give an output of 2 volts. So as I want to find all the different values, just drag it down, you will get all the different. Again, the problem here is, again, you got the decimals and the DAC don't support this decimal, so you have to round it off. Okay, how to round it off is, again, you go into this equation. Okay, round, use the round equation, round this value to 0 decimal point. That means I don't want any decimal point. So okay, so just press enter. So now you got this value. Okay, just click on it, drag it down. So now you see all the values are now converted into what you call decimals. Okay, generally when we write the program, we in lookup table we will mention the value in hexadecimal. Even decimal will work. So if you want to convert it to hexadecimal, then Excel has a function decimal to hexa. Okay, then you can put this value, the required input. Okay, decimal to hexa of this cell. Okay, let me delete it. Okay. Do it again, decimal to hex of this cell. Okay, this cell is E7. I will write it down, it is not getting selected, so it is E7. Enter. Why it is 64? Okay, 64. 100 in decimal is 64 in hexadecimal. So I want to apply this same thing to remaining cells, so just drag it down, you get all the hexadecimal value. So this is how the hexadecimal value you will get ultimately, and these are the values to be loaded in the lookup table of your that means microcontroller program of your FPGA, in order to get a sine wave with 16 what you call samples, with 16 right, with 16 what you call samples in 2 pi. Okay, thank you.